Guys and girls, it's Know It time!
Alright guys, brand new chapters. We're going to start with trig. Now trig is unlike what you did in grade 10. It's unlike what you did in grade 9. We're not here to find SOHCAHTOA. We're not here to find the missing angle. That's too easy. Okay? In grade 12, you're going to learn trig. But before I can teach you about trig, your lesson today is on basic vocabularies. You can't do trig until you master some English words first. Vocabs. Okay? In grade 4, maybe grade 5, you were tricked into buying something called a little protractor or a little compass. Yeah. How many of you remember that stuff? Yeah. You used it for about 1 day of your life and you threw it away. Mm-hmm. And then but the thing is, they advertise that to students, say you must need for school. Guys, you don't really need that stuff because no one uses a compass or a protractor anymore. Now, in a compass or protractor, you measured angles using degrees. That's a unit to measure angles. That was easy. Measure angles. You use a protractor, you measure it, and then your teacher gives you a little star, says good job. Okay? If I ask you, just draw a little quadrant. Draw in 45 degrees right now. Quadrants system works like this. This is known as quadrant 1. This is quadrant 2. Notice how I'm going counterclockwise. Quadrant 3, quadrant 4. If I ask you draw 45 degrees right now, take a guess. I'm going to pause it. Okay. We're 45 degrees. Just Kieran, what quadrant are you in? 4. Whoa. Well, you could do 4 if you want, but let's be more. You're in quadrant 1. Because when you label, this is going to be 0. This is 90 degrees right here. So this is 180. This is 270. So I'm going to say this right here is a little 45 degrees. Okay, that was back in the days. Fun times. You remember then. For some of you, it's been a long time ago. That was the degrees. In grade 12, we don't use degrees anymore. Degrees is child's play. In grade 12 and senior level math, you're going to use a new term. This is called radians. Radians is another unit to measure angles. That's what radian is, another unit to measure angles. I can measure in degrees, or I can measure in radians. Your scientific calculator sometimes has a little d, or has an r, or has a g. D stands for degrees. R is radians. That's what we're working on, radians. G, gradients. Something for engineering, which you learn later. Now, just like inches, for example, 1 inch. Guys and gals, take a guess. What is the exact measurement of how many centimeters that is? Aaron, what is it? 2.54. That's correct. See, an inch is related to a centimeter. Your finger is actually a ruler in disguise. Your whole hand is a ruler. The inch, take your look at your index finger right now. The top of your index finger to the first notch, on average, is exactly 1 inch long. Take a ruler and measure right now if you have a ruler. Measure from the top of the finger, index finger, to the first notch. It should be exactly 2.54 if you're the average human being. Okay? So your whole body is really the thing.
I'm more average.
Are you average? Well, what's your first digit? Get a ruler. Get a ruler, right? Now, the question is, how is degrees and radians related? Because I just taught you the relationship between inches and cm. But what about degrees and radian? Here's the relationship. we're going to write down pi by 180 or 180 over pi. I'm going to write a few later notes on star. Whatever units you want. Whatever units you want. That unit must go on top. Must go on top. Okay. Whatever unit you want, that unit must go on top. It sounds confusing right now. I'm going to add in a few more labels for you. 180 is the symbol for degrees. Pi is radians. Here's your question. They're going to ask you, I have 60 degrees right now. They want to convert to radians, rads. Okay. This is what they say. I have degrees, but I don't want to work with degrees because in Math 12 is all radians. Radians is quicker, better. So what we're going to do is go 60. You're going to times. I have two fractions to work with. Either pi by 180 or 180 over pi. You're going to use only one of those fractions. Think about which one I'm going to use. 2 times by 60. And multiply and simplify, and then you get your answer in radians. Guys, gals, I'm going to pause it. Ooh, whoa. I have to use, see, I'm converting to radians, right? So I have to use a fraction with radians on top. Which fraction has radians on top? This one, right here.
But didn't you say the number has to go on top?
It says whatever unit you want, that unit must go on top. See, I want radians. So I'm going to choose a fraction with radians on top. So I go times pi over 180. So go ahead and multiply this out. You get 60 pi over 180, which simplifies to pi by 3. You can leave your answer in fraction form, which is better, which is what the book does. Or, if you want, let's grab your calculator out right now and convert it to decimals. So you go divided by 3, 1.05, for example. So really, I can have two ways. The book, or standard form, the best form is to leave it as a fraction. Try this. What if I give you 2 pi by 3? First of all, Randeep, is this radians or degrees, first of all? This is radian. If you see pi, it's radians right off the bat. I don't like working with radians. Some of you said, Mr. Snow, can I just work back to degrees? Find out how many degrees that is. I'm going to pause it and let you try this on your own again. So you guys, to convert, I just take my original question and I multiply. I have to multiply by one of these fractions right here. I want degrees, so 180 is a degree symbol, so I multiply by 180 over pi. Okay, go ahead, multiply, simplify, and you get a nice answer. Robert, what did you get? You didn't do it? Divided by 3 is 110. Yep. So your answer is 120 degrees. Guys, voila. Easy? It is pretty easy. Next phase. So you know one vocabulary. One is radians. Now, I'm going to teach you how to graph theta in standard position. Standard position. All you're going to do is tell me what quadrant you're in. That's it. So we have a quadrant system, and all you're going to do is tell me what quadrant is your line in. Quadrant 1 we know is always here, no exceptions. Quadrant 2, 3, quadrant 4, no exceptions to this rule. let's say I have theta equals to 300 degrees. Yep. Theta equals to 300 degrees. Quadrant 4. Abraham, what quadrant? Quadrant 4 is correct. See, it's in quadrant 4 because it's 0, 90, 180, 270. So all you're going to do is just draw a line anywhere you want. Quadrant 4. And this is what you got to do. You're going to draw a little trail from your starting line all the way to your ending line. There's going to be some more terminology he's going to teach you. Highlight this part of the x-axis, please. This is your starting line. In this, there's a mathematical term for this. This is called the initiating arm. Initiating arm. The arm that moves around. There's an arm that moves around, this arm right here, that travels around. This is called your terminal arm. So there's the terminology. It's going to hook at you left and right. Terminal arm. Terminal arm. And we draw our little trail from the initiating to the terminal. That's 300. I call that my snail trail because it looks like a snail shell later. What about this one? Theta, good luck, equals to 492 degrees. I'm going to pause it and let you have a crack at it. If you're right. I walked around and a lot of you say, hey, that's in quadrant 2. Again, watch what I'm going to draw. If I go all the way around, I'm at 360. But the problem is, I have to go a bit more than 360. So let's just do this right now. 492 minus 360. That gives me 132. So really, I'm just plotting 132. 132 is going to be somewhere here. Draw it in. And when I draw on my snail trail, look, I go all the way to here. See, it looks like a snail shell. So I call this my famous snail trail to show you how many times it went around. Yeah, that was easy. Now, next question. What happens when you have a negative angle? What happens when you have a negative angle? You go the other way is correct. The answer? Go the other way. The other way. Everything stays the same except you're going to retwist your brain to go the other way, which is clockwise. So I'm going to give you a question. We're going to work through this together. Theta equals to negative 220 degrees. Plot it in, show me my snail trail, and tell me what quadrant you're in. Again, I'm going to pause it. Just in. So guys, gals, so watch what I'm going to do. See, I have a negative quadrant, so I'm going to highlight this. Just highlight to make sure you know it's negative. Now, when it's negative, we're going to think that we're going to go the opposite way. So I'm going to relabel everything opposite now. Instead of 90 being up here, I'm going to put 90 down here. Okay, just retrain our brains because we're going this way now. 180, 270, right here. So, see, that negative means you're going to relabel everything, go backwards. 220 is between 180 and 270. So draw on your line right now. Do it. Come on. There we go. Oh, no. Okay, let's just do it by hand. So guys, this should be right here. And when you draw on your snail trail, look what I'm doing. I draw backwards this time. And it goes there at 220. Very nice. Keep it simple. Hot shots. Try this. You can do degrees. How many of you can work with radians? Theta equals to 3 pi by 4. Okay, crack lacking. I'm going to pause it and let you saw radians, say, hey, Mr. This was easy. I hate radians, so I'm going to convert to degrees. So you went this. You went 3 pi by 4 times 180 over pi. You punch this in your calculator. So go punch in my calculator right now. 3 times 180 divided by 4. You have 135 degrees. Then you went 135. You sketched out your thing. You did 0. You labeled this very nicely. 180. And so on. And then you measure with a protractor and say, like something around there. Okay. And then you drew in your snail trail right about there. And that took me about maybe 1 or 2 minutes. Okay. In this question, if you take longer than 5 seconds, you will fail this class. You have to do it in under 5 seconds or less. We're going to have a competition on who can do it under 5 seconds or less. It's called the last student standing. I'm going to show you the technique. My technique, I'm going to pass it to you. I pass on this to from year after year. And everywhere, first student said, Mr. Snow, degrees is so much easier. Why can't I stick with degrees? Because in real life, your test is timed. You have to be able to do this in your head just by looking at it. Okay? I'm going to work with radians. I'll show you the technique to working with radians. Once you understand the technique, you're like, oh my god, radians is so much easier. Okay? Because 90% of your question is all radians. No degrees. Doesn't work anymore. When you label radians, this is still 0. Okay. Would you agree that from here to here is 180 degrees? 180 degrees, but we're not using degrees anymore. We're working with radians. Figure out what is that in radians right now? Pi. So put in pi for me. That's pi. Now, I look at this whole entire thing, and I want you to highlight this 4 right now. 4. Okay. So whatever that denominator is, you're going to put pi over that. Over 4. Just put it over 4. But the problem is, I know this whole entire thing has to be pi still, so there has to be a number in front of here to make it pi. So we'll put 4. Because would you agree, 4 pi by 4 is the same thing as pi. There's no difference. So from here to here is 4. Guess what this piece must be in terms of pi? So label this as 2 pi by 4. 2 pi over 4. So where's 3 located? In between 2 and 4. And draw in your line. I'm going to give you another question. We're going to work together before I give you the competition. I want to see who the fastest student is, who can compute this on their head in one shot. 2 seconds or less is the time you should be aiming for. Okay? Every year I do this, 80% of students can do this under 2 seconds or less. Question? I'm going to explain again, don't worry. Let's say I give you this one. Let's again, 7 pi by 6. Right off the bat, let's draw a quadrant system. Please do not convert to degrees. If you convert to degrees, it tells me you're afraid. It tells me you're weak. You're going to go 0. I want you to label this piece right here, right now. That's a key. The key is to label this one piece. That's the key. Okay. Giselle, what is this going to be? Sorry. Pi over 6. So for now, we'll just label it pi. We'll work together on how to get this. Pi. Because we know that's 180 degrees. 180 degrees is always pi. And I look at this. Hey, look, there's the 6 here. Why don't we put it over 6 right now? 6. But it has to be pi, so there has to be a number here. Guys and gals, figure out what number goes there. Okay, 6. So we'll put in a little 6 here. So now, if you want, I want you to just practice for now. Just take a simple practice. Label halfway here and label the mark down here. That's all we're going to do. Just practice. Sim, what is the mark up here going to be?
5 over 6.
Whoop, whoop, whoop. Nope, not 5. 3. Because halfway. Because remember, some students don't even need to label. Eventually, I will take all your labeling away. You can see in your head. Okay, we're going to label down here now. Paul, what's down here? 9. So now I look for 7 pi by 6. Where's 7 located? In between. How do you know how close? Doesn't matter how close. I just need to know what quadrant you're in. Guys, gals, ready to try this? I want you to try it without drawing. Just imagine in your head where everything is located. Let's see who can do it under 2 seconds or less. It's called the last student standing. Last student standing gets a card. We're going to go row by row. And I'm going to show you how the game works. For now, we're going to have some practice before I put pressure on you. Theta equals to 5 pi by 4. 3. See how fast that is? They just looked at it. And some of you say, Mr. I didn't pick up a pen yet. Guys, gals, if you have to pick up a pen, you're doing it wrong. So again, practice right now. What you're going to do is draw a quadrant and just label slowly. You get better. In my class, you have to do it under 2 seconds or less. That's the speed you got to function at in order to understand trig. Okay? Anything longer than 2 seconds means you don't understand it. Trig is all about understanding. I want you to go ahead and label this piece right here. That's all we're going to do. Just label this piece. Kavina, what's this piece going to be?
4 pi by 4.
4 pi by 4 is correct. Hey guys, gals, if this is 4, 5 has to be just one more. And Bana, so 5, where's 5 going to be? Right here, 3. Was that easy? Oh yeah, that was pretty easy. Try this one, a bit more challenging. Some of you want a good challenge? Let's try this one. Theta. 9 pi by 4. Good luck. So go ahead, try it. 9 pi by 4. If you need to, draw it out. And see if you get 1. That's a, sorry? 4th quadrant? Nope, not 4th quadrant. 1 is correct. That's the speed you got to work at. Okay. So again, if you're lost, watch what we're going to do. Again, I always label in my head, this is 0. This is 4 pi by 4. Okay, look what I'm going to do. From here to here, I know it's 4. If I go halfway again, Curvier, where would I be at? 8. But I don't want 8, I want 9. So 9 has to be just a tad bit more. Just a little bit, not a lot. Guys, gals, that's 9 pi by 4. Try this one. Some of you say, hey, I'm starting to get the hang of this. Theta equals to negative 5 pi by 3. I'm still waiting for the right answer. Oh, sorry? 3? 3? 2? 2? Only 2 people got it right. The answer is quadrant 1. Why is it 1? Look what I'm going to do. I want you to highlight there's a negative right here. Okay, so look how I'm going to draw this. Okay. This is still 0 right here. 0. This is 3 pi by 3. Agree? Now, negative means I go clockwise. From here to here is 3. Agree? If I go all the way around, I would be at 6. If I go all the way around. But I got to stop just slightly before 6. And slightly before 6 is going to be quadrant 1. Guys, gals, I'm going to give you 2 minutes to practice this. We're going to have a competition. Last person standing. We're going to have row by row. We're going to see who the fastest in each row is, and you're going to keep on challenging. If you lose, you sit down. Only you only get one guess. You say it wrong, you're out. So this is a game of speed and accuracy. We're going to see who is the last student standing. I'm going to pause. Here is the next term I'm going to teach you. This is called the reference angle. Nope. Reference angle. Now the reference angle, again, you need to know a few things. Write down star. Reference angle is an angle that's based on understanding. There's really no mathematical formula for this. Well, there is, but it's more to do with logic. I'd rather you understand logic instead of giving you a bunch of formulas to memorize. The smallest positive. I need you to highlight the word positive. Reference angle can never be negative, always positive. Okay? No exceptions to this rule. The smallest positive angle, the terminal arm makes with the x-axis. This is called the reference angle. Okay? I'm going to give you a question. I'm going to say theta equals to 120 degrees. In order to find reference angle, I want you to plot 120 degrees right now. So tell me what quadrant you're in. Oh, well, 1. No, not 1. 2. So let's draw in quadrant 2 right now. Now, some of you ask me to know where exactly in quadrant 2. It doesn't matter where in quadrant 2 it is. I just know it's in quadrant 2. Done. Draw your snail trail for me, please. Because remember, when you draw an angle standard position, don't forget this. This here is 120 degrees. This here is 180 degrees. Highlight, shade in, where do you think the reference angle is? Shade it in. It's the smallest angle you make with the x-axis. And there's only this little angle right here. This is your reference angle. Shade this angle in. Okay, 60. Because by logic, I go up to here is 120. If I had gone all the way around, it's 180. So Erica, what is that missing angle? What is your reference angle right here going to be? 60. Because I'm missing 60 degrees. So this is called a reference angle. The faster you are at figuring out what quadrant you're in, the easier reference angle becomes. Let's try it with radians instead. Again, the key is to understand how the radian system works. Theta, 5 pi by 4. What's your reference angle? Whoa. Look what I'm going to do. I'm going to draw a quadrant. Do it. 5. I know I'm in quadrant 3. So draw in quadrant 3. Okay. And like I said, if you need to label, go ahead and label this as 4 pi by 4. Okay. If I go here, this is 4 pi by 4. If I go all the way up to there only. My reference angle is this little tiny angle right here. That's the reference angle. No tricks. Therefore, this missing piece right here, Jasmine, what's this missing piece? So watch again. If I go up to here, from here to here, only, right? That's 4. But if I go all the way here up to here, this is 5. So the missing piece has to be 1 pi by 4, or simply pi by 4, because let's explain this again. Up to here is 4, but I'm at 5, so this one little missing little piece right there has to be pi by 4. This is called a reference angle. Try this, a bit more challenging for you. Theta equals to negative 2 pi by 3. Quadrant, and find the missing piece. Pi by 3? Pi by 3 is correct. Okay, so let's look at this one. So if I do a negative 2 pi by 3, I should be in quadrant 3 right here. I go backwards from here to here. This is 3 pi by 3. This is 2 right here, 2 pi by 3. No tricks. Armor Paul, so what must the missing piece be? Pi by 3. And that's called your reference angle. See, notice I'm always forming with the x-axis, never the y-axis. And even though I'm working with negative, my reference angle, that piece, is always positive. Some of you will put negative. I will take marks off. You will get it completely wrong. This is called the reference angle. Good luck. I'm going to work backwards this time. I'm going to say your reference angle is in fourth quadrant. Your reference angle equals to 40 degrees. Find theta. I'm going to pause it. So to just draw a rough sketch. Draw my sketch. I'm in the fourth quadrant because it says I'm in the fourth quadrant. Now, my reference angle right here, this is 40 degrees. Okay. If I do the positive way, Abraham, what is that blue angle going to be? 320 degrees is correct. Because if I go all the way around, I'm at 360. Now, Sean brought up a good question. Say, Mr. Snow, how do you know 320 or negative 40 degrees? Both answers work. Okay. 320 is a more common answer. I may say theta is a positive angle. Guys, and one more thing that I'm going to show you before, and then after lunch you get the time to practice this. The last thing is called principal angle. Principal angle is the last vocab you're going to learn for today. And then I'm going to wrap up, and then it will be lunchtime, and you're going to do this after lunch. I'll give you time after lunch to work this. Principal angle is this: an angle between 0 and 360 degrees. That's called your principal angle. It's an angle between 0, or if you're working with radians, 0 and 2 pi. That's if you're working with radians. I'm going to say theta equals to negative 300 degrees. What is your principal angle going to be? To figure this out, I want you to draw a negative 300 right now for me. Tell me what quadrant you're in. So, negative 300, you're in quadrant 1, is correct. Okay, I'm just going to draw it in, label. Again, look at my snail trail. This is negative 300 degrees. But principal angle means it's an angle from 0 to 360. I can go counterclockwise, or I can go from here to here, and I get the exact same positioning. Okay. So Kieran, what must this angle be right here? 60 is your principal angle, that's correct. So it's an angle between 0 and 360 degrees, because it's the exact same thing. Try this one. What if I give you 9 pi by 4? 9 pi by 4 we know is not my principal angle because it's beyond that range. Find my principal angle. Okay. Draw it out. The best way to do is just draw out and draw your snail trail for me. That's the key to doing this. It takes practice, but sooner or later you can do this in about 2 seconds just by looking at it. That's the speed I want you to be at. Nine pi by 4. Gary, what quadrant are you in? 9 pi by 4. Quadrant 1 is correct, so draw in quadrant 1. If I do in quadrant 1, look at my snail trail from here all the way to here. But really, I don't need that piece. I only need this piece right here. Because it has to be from 0 to 2 pi. So this piece has to be pi by 4. Okay, one last one. Good luck with this one. 900 degrees. I'm going to pause it, let you try. So really the key is, let's draw in 900 degrees. I walked around and somebody said, Mr. If I go this, 360, 720. Now, where does 900 lie? Ryan, where's 900? Sorry? So quadrant 2 right here? Like that? Okay. And then you're going to say this is 900 degrees? So therefore, what's your principal angle? 180 is not correct.
What's it, 20 degrees?
20 degrees. First of all, the key is to figure this out. What is this mystery angle right here? This is what you want to know. That's the mystery angle right there. So to figure this out, let's clear all this up. 900 minus 360 minus 360. Oh, hang on. Your angle is in the wrong positioning. This is reason. 180 is correct, but the way you draw it is wrong. Okay, when you draw your line, see this is your line should be right there. That's where it is. That should be 180. So your answer was correct, but your line was wrong, Ryan. Okay, that's the way it is. Because that's 900 degrees, so your answer is 180. Guys, gals, your work. Page. We're done. 60. Numero 1, 7 to 12. That's it. Robert. Why isn't answer 0? Because your terminal arm is this yellow arm right here, right? Now, so that's your terminal arm. If it's at 0, that means your back starting position. This is 100. This reference angle? It is, but we're talking about principal angle. Okay? The question was principal angle. That's the reason why. So guys, that ends your lesson.